What if I told you some of the strangest medical stories people still repeat today weren't solved by magic? They were solved by boring evidence. After years of confusion and wrong leads. Stick with me, because this countdown visits 5 outbreaks and treatments that once looked supernatural, then got untangled in real time. And here's the point. You don't just get trivia. You get a map for how medicine corrects itself when the evidence finally steps in. We'll go one by one. Each chapter starts with a mini hook about the mystery. Then we slow down for what made it confusing, what people tried, and what evidence explained it. Think of it like pattern chasing under pressure. People see something scary or strange, and they reach for the first explanation that feels complete. Now let's start the countdown, because number 10 is where the patterns started looking almost impossible to decode. Number 10. The sleeping illness that kept changing its rules. In the late 1800s and early 1900s, big parts of Central Africa dealt with what people called sleeping sickness. This wasn't just fatigue. The disease dragged the body into a slow collapse, and even behavior and movement could shift over time. At first, people were stuck on confusion. Symptoms seemed to change, almost like the illness was telling a story, but nobody could see the author. The weird part is that it didn't behave like one simple event. It had stages, and early symptoms could be vague, while later ones looked like the world was gradually shutting off. Then a major breakthrough landed. This wasn't just a hospital tragedy, it was a biological cycle. That means you have to look at vectors and transmission. Eventually, researchers identified the parasite involved and the key role of a fly as the transmission link. The story shifts from "why are people collapsing" to "how is this traveling?" And this is the theme kicker for the countdown. If you don't know the transmission route, you can't target prevention. You're stuck treating symptoms while the spread keeps running. All right, number 9. The outbreak that looked like food until it wasn't. There have been outbreaks where the early story sounded like everyone ate the same thing. Honestly, that instinct isn't stupid. When people share meals, they share exposures, and foodborne infections are real. But sometimes the shared meal explanation is only half right. The clustering might reflect a shared setting or a shared route that wasn't actually the kitchen. This is where evidence-based investigation matters. Investigators ask who got sick, who didn't, how fast symptoms started, and whether the timing makes sense. When you plot timelines, the outbreak can start to talk back. If symptoms appear too fast or too slow for the alleged food route, that mismatch becomes a clue. So, the correction usually comes from comparing experiences. Investigators build contact maps, check locations, and test samples when possible. Mini payoff. If a mystery feels obvious, that's when you should get more systematic. Medicine's superpower isn't confidence, it's revising when evidence disagrees. Now we pivot to number 8. The treatment people swore by, even when it wasn't clear why. Some treatments spread through testimony and word of mouth. Here's the problem. When people improve after a treatment, it doesn't automatically mean the treatment caused the improvement. Illness can fluctuate or resolve on its own, and it's not just biology, it's the system. Without controlled studies and consistent ways to measure improvement, you end up with stories instead of evidence. Evidence-based medicine adds a barrier between promising idea and final claim. You don't just ask if someone got better. You ask how it compares to something else or nothing at all. Over time, medicine learned that many miracle cures were a mix of natural recovery, placebo effects, and confirmation bias. Evidence doesn't just correct wrong explanations. It protects you from our most persuasive experiences. Okay, next at number 7. When bacteria became suspects before the lab could fully speak. There's a phase where you can identify a suspect, but tools still limit interpretation. The catch is correlation versus causation. Finding bacteria in sick tissue might be the cause, or it might be the body weakened in a way that let microbes move in. The correction comes when evidence triangulates. You test whether targeting them changes outcomes. Look for consistent patterns and compare affected and unaffected cases.